In this lecture, we're going to adapt the cluster analysis techniques that we developed in the previous two lectures and apply them to a spatial setting. Can we identify different clusters in space? And there's lots of ways to do this, but one simple way is just to do the same type of k-means analysis we did in the previous lectures, but just cluster on the x and y coordinates, or the latitude and longitude. So rather than using non-spatial variables like voting, we're just clustering on these two spatial variables, x and y. So the example we'll look at clusters of marijuana dispensaries in Los Angeles using the data from the City of LA's Socrata website. So we can export and we can get the API endpoint here and use requests, as we did in Module 1, to get this into pandas. So first question, well, where are our spatial data? Well, it looks like it's in this location 1 column over here. So how can we extract it? Well, let's look at the first row. So we have a latitude and longitude, which is actually embedded in a dictionary. So I want you to pause the video and see if you can create two new columns, lat and long, that extract these coordinates, latitude and longitude, from each row of a data frame. Well, how did I do this? Well, let's use our anonymous lambda function. So I'm going to take this location 1 column and apply. What function am I going to apply? I'm going to apply a lambda function. So I'm going to take each value of location 1. I'm going to extract latitude from a dictionary. So this is a dictionary, so I can just specify the key, which is latitude, and then convert it to a float, and then do the same for longitude. OK, well, I get an error here. What's my error? It says float object is not subscriptable. Well, what's causing this problem? Not immediately apparent to me, but let's look at the first, say, 20 rows. OK, so it looks like there's a null value here, and maybe that's some of the problem, that I can't apply my dictionary key to this null object. So what if we just drop our NAs, drop anything that's null in this location 1 column in place, and then do the same 2 lines as we did before. OK, that seemed to run. OK, and we get 2 new columns that have a mean of 33 and 115. These seem like latitude and longitude coordinates for the city of LA. But notice we do have some errors in the input data from these descriptive statistics. We have one dispensary that has a 0 latitude. That sounds like a very unfortunate place to have a dispensary. Or a longitude of 0. And there are also some locations with improbable values as well. So I'm going to crudely limit these dispensaries to those that are in Los Angeles. And I just eyeballed these latitude and longitude limits from a map. So I'm going to filter by everything that has a lat of greater than 33.6 and less than 34.8, and do the same for longitude. So this is just taking the subset that passed this condition, filtering the data frame, and putting it back in the data frame with the same name as before. And then, as we've seen in previous modules, we're going to use points from XY to convert these latitude and longitude coordinates into a GeoPandas point. And OK, that looks reasonable if we plot it. So now we can do our clustering. So just as we did with the non-spatial data, we might want to experiment with different values of k. Try different numbers. We tried 5, we tried 10, until we get a sensible result. Here, let's try with 20 clusters. Now, technically, we probably should reproject before we start. Why? Because a degree of latitude isn't the same distance as a degree of longitude because of the curvature of the Earth's surface. But let's not worry about this now for simplicity's sake, but you might want to reproject into state plane or another equidistant projection. So we've seen this code before. We'll import our k-means, we'll initialize our object specifying 20 clusters, and then we'll fit it. What are we going to fit it to? Just the 2 latitude and longitude columns. And then we're going to get the labels and add a new column with the cluster label to our data frame. So it looks like we have a new column here, which is our cluster ID. So that seemed to work. Now let's map them. Well, this is pretty much identical code to what we've used before. We're just plotting the cluster ID with a categorical code. And we don't necessarily need the legend because there's lots of them and the number of the cluster perhaps isn't as relevant. So we see that there's these nice little clusters here. There's a cluster down here in South LA in Long Beach. There's a big cluster in downtown. And there's several clusters in the San Fernando Valley and one here in West LA. So our k-means algorithm also seems to be producing sensible groupings in space as well. We could also map the centroid of each cluster, but I'm going to leave that for you as an exercise. Here we're mapping each polygon, and let's map the centroid of each cluster as well. And if you want a hint, the raw latitude and longitude values are going to be found in this k-means cluster centers object. The takeaways I'll leave you from this lecture are that spatial clusters work in a really similar way to non-spatial clusters. And they're good at identifying different groupings in space, but perhaps they can also identify hotspots as well. So let's leave k-means here. Let's leave our machine learning part of the course here. And in the next module, we're going to turn to some text analysis methods and identify sentiment, topic modeling, and other types of natural language models.